Good evening. I'm going to give you a video here on graphing rational functions. It's just going to be some basic information, but it'll help make the notes a little bit shorter for class tomorrow. So I'm just going to show you how to find a few things. I'm not going to show you how to graph anything just yet. We'll do that in class tomorrow, but I am going to show you how to find some things that will help you with the graph. This whole next unit is graphing rational functions, and so we'll do graphing every day, and we'll just kind of add one piece to the graph each day where you're finding something new, because these problems can get kind of long. But just want to talk about four concepts here: x-intercepts, y-intercepts, vertical asymptotes, and horizontal asymptotes. And I've already written out for you what you do to find each of these, and I'm going to give you an example of how to find them. But first of all, an x-intercept, that just simply means where the graph crosses the x-axis. And the way we find that is we set the numerator equal to 0. So whatever's in the top, we set it equal to 0, and then we solve it. Kind of like we were doing when we did the rational inequality problems. That was one of our steps. So we'll set the numerator equal to 0, we'll solve it, and then when we get that answer, whatever the answer is, I put that first, and then comma 0, and that would be my ordered pair for the x-intercept. The y-intercept, same idea. It's where the y, or where the graph crosses the y-axis. In order to find the y-intercept, we take all of the x's in the problem and we turn them into zeros, and then we solve it from there. And the way we would write the y-intercept as an ordered pair is we'd put 0 first, and then we would put the number that we found. And then next we have vertical asymptotes. Now vertical asymptotes are key because they really help us define where our graph is going to be. So a vertical asymptote, it's simply just, basically it's a line on the graph, and we'll draw it using a dotted line, but it's a line on the graph that the graph gets really close to, but it never crosses. And they really kind of help define where our graphs are set up. So we'll talk about those in class tomorrow, really, when we're graphing. But I'm just going to show you how to find one right now. And in order to find a vertical asymptote, you just take the denominator and you set it equal to 0, and then you solve it. And again, we did that when we were doing the rational inequalities problems. That was one of the steps. And then we also have horizontal asymptotes. Now horizontal asymptotes are sort of the same thing as vertical, except obviously they're horizontal lines. And again, we'll make those as like dashed or dotted lines on the graph. But they're a little more complicated to find. To find a horizontal asymptote, you have to compare the degree of the top part of the fraction with the bottom part of the fraction. Now by degree, we simply mean the highest exponent that appears in the top or in the bottom. So, for example, if we had an x squared in the numerator and that was the highest exponent for x, then 2 would be the degree. So what we do is we compare those. Now, here's how we do that comparison. If the degree of the top is smaller than the bottom, then my horizontal asymptote will be y equals, which makes y equals 0, which means it will be the x-axis. If the degree of the top and the degree of the bottom are equal, then it's a little more complicated. You have to look at what's called the leading coefficient, and I'll show you that in the example that I'm going to do. And then if the degree of the top is larger than the degree of the bottom, then you have no horizontal asymptote, or none there. All right? So let me give you an example of how to find each one of these things. And then tomorrow in class we will go over how to find these and how to take this information and draw the graph. Okay, so I have an example here. We've got f of x equals 3x plus 4 over x minus 2. That is a rational function because it's a fraction. And so now we're going to find each one of these: the x-intercept, the y-intercept, the vertical asymptote, and the horizontal asymptote. So we're just going to start off with the x-intercept, and the rule was to take the numerator, which is 3x plus 4, and set that equal to 0 and solve it. So I'm going to subtract 4 from both sides. We get 3x equals negative 4, and then we're going to take and divide by 3, and we get x equals negative 4/3. So my point, or my coordinate, would be negative 4/3, comma 0, and that would be my x-intercept. So what that means is the graph crosses the x-axis at approximately negative 4/3, 0. All right. Now to find the y-intercept, we take all of the x's in the problem. So up here and right here on the bottom, we take those and we're going to put in zeros for those. So I'm going to have 3 times 0 plus 4 divided by 0 minus 2. So I just put in zeros in place of the x's. So 3 times 0 is just 0. So I end up with 4 over negative 2, which gives me negative 2. Now that is my y-intercept. So for my y-intercept, I would write it as 0, negative 2. So what that means is the graph crosses the y-axis at 0, negative 2. For the vertical asymptote, we're going to take and set the denominator equal to 0. So that's an easy one here. We just take x minus 2, set it equal to 0, and we get x equals 2. That's my vertical asymptote, and I'll show you how to put that on the graph tomorrow. And then for the horizontal asymptote, we have to look at the degree. Now, when we're looking at the degree here, all right, we want to look at the highest power of x in the numerator. Well, all we have here is an x to the first. So the degree of the numerator is 1. And down here in the bottom, we also have an x to the first, so the degree of the denominator is also 1. Well, these two degrees are equal, which means we're going to be looking at my second case here for horizontal asymptotes. The degree of the top is equal to the degree of the bottom. And it says what I do to find my horizontal asymptote is I divide the leading coefficients. Well, the leading coefficients are the numbers that are in front, or the coefficients of these x's. So the coefficient for this one is a 3, and the coefficient for this one is a 1. So to find my horizontal asymptote, I simply divide that 3 and that 1. So my horizontal asymptote for this problem would be y equals 3 over 1, or I could just write y equals 3. And again, I will show you how to put that on the graph tomorrow so that you can graph these.